Integration by parts. Sometimes the integration by substitution method is not really working for integrating the product of two functions. So let's quickly recap the product rule first. We know that when we try to differentiate f of x times by g of x, that will give us f dash of x of g of x plus f of x times by g dash x. Now we integrate both sides, and then this is the result that we get. And we're going to leave this part on one side of the equation and everything else on the other side. So I'm technically moving this to this side, so that will give us f of x times by g of x minus integration of f dash of x g of x dx. We call this is the formula for the integration by parts. Now we just need to be careful with the selection of f of x and g dash, because we have to make sure that g dash can be easily integrated, as well as this part here needs to be easily integrated. Let's have a look at example. Integration of x times cosine x dx. Let's go by order first. So let's say our f is x and our g dash is cosine x. So from f, I can find out what f dash is, so that's by differentiation, which is 1. And from g dash, by integrating it, I can figure out what g is. So therefore, this is sine x. So now I know f dash g dash. Now I can perfectly use the integration by parts formula here, which is on the right hand side. So let's start with fg. So f is my x times by g is my sine x minus integration of f dash, which is 1, times by g, which is sine x. So now we have x sine x minus integration of the sine x, which is negative cos x. So negative negative become positive, so that's why it's plus cos x. And don't forget the plus c, because this is the indefinite integral. Now please pause the video here and try these two questions by yourself and come back to check your answer. So question 1, I will choose f of x to be x, and g dash is my sine x. So differentiated f will give me f dash equal to 1, and when I integrate g dash, that will give me g equals to negative cosine x. Now let's substitute these into the integration by parts formula. So we start with fg, so that's x times by negative cos x, so the whole thing is negative x cosine x, minus integration of f dash, which is 1 times by g, negative cosine x of dx. So we have negative x cos x, negative negative become positive, and the integration of the cos is sine, so therefore it's plus sine x plus c. Again, this is indefinite integral, so you can't forget the plus c. Now question 2, if you look at question 2, you're like, oh, I don't know how to integrate natural log, because natural log can't be integrated. But this is not a product. But we can rewrite this so that it will become a product. So we can say this is 1 times natural log of x dx. Now, notice that natural log of x can't be integrated. So that means we can't choose this to be g dash. So therefore, my g dash has to be 1. And my f needs to be natural log of x. So f is natural log of x, so therefore my f dash is 1 on x, g dash is 1, so therefore g is x. So now I have f dash g dash. Now we can actually use the integration by part. So therefore this equals to fg, so which is x times by ln x, minus integration of f dash g, which is 1 on x, times by x dx. Now you realize it. whatever's in the integration can be simplified. So therefore, it is same as integration of 1 dx. So therefore, the final answer is x natural log of x minus x plus c. Again, please don't forget plus c for the indefinite integral. Now please try question 3 and question 4 and come back to check the answer. Question 3. We have integration of x times by ln x. Now again, natural log of x can't be integrated, so it can't be g dash. So therefore, we're going to set this one as our f and x be g dash. So f is ln x, that means f dash is 1 on x, and we know g dash is our x, therefore our g is x squared on 2. Now we're going to substitute into the integration by part formula. So start with fg, so that is x squared on 2 times by ln x minus integration of f dash, which is 1 on x, times by g of dx. Now you can see this can be simplified. So therefore, we can continue and integrate half. We can take that constant out, x dx. And that is same as x squared over 2 ln x minus half times by x squared over 2 plus c. Let's continue simplify it. So therefore we have x squared on 4 for this part plus c. Question 4. Suddenly you see, oh, this is not the product, it's an quotient. But let's rewrite this so that it can actually look like a product. So ln x times by x to the power of negative 2 of dx. So now, again, natural log of x can't be integrated. So therefore, it has to be f. So f is our natural log of x. F dash is 1 on x. And our g dash is going to be x to the power of negative 2. And therefore, my g is x negative 1 over negative 1, so which is negative 1 on x. Now let's substitute everything into the formula. So that will give us negative 1 on x, natural log of x, minus integration of f dash, which is 1 on x, times by g, negative 1 on x dx. So this will give us natural log of that, and then with negative 1 on x, negative become positive, so it's positive integration of 1 over x squared dx, which is actually the same as x to the power of negative 2. So negative ln x over x plus integration of this, which is plus 1 to the existing power and divided by the new power plus c. So therefore, the final answer is negative natural log of x minus 1 on x plus c. Sometimes you have to do integration by parts more than once. So let's have a look at this example here. So I have integration of x squared times by e to the power of x. So I'm just asking myself, which one should be f, which one should be g dash. So for this case, both of them can be integrated. So I'm going to choose the first one as my f and the second one as g dash. So if I differentiate f dash is 2x, and integrated g dash, that will give me e to the power of x. So let's start with substitution. So this will give us fg is x squared e to the power of x minus integration of f dash, which is 2x, times by g, which is e to the power of x on dx. Now we have another problem here because we can't really integrate the integration of 2x times by ex. So we're going to use the integration by parts again. So we're going to let this time, this one be f, but I think I'm going to choose different letters so we're not confusing ourselves too much. So I'm going to let this one be u, this one be v dash. So therefore my u dash is 2, and my v is integrating the v dash and still e to the power of x. So we're going to substitute this one. So I'm going to actually start from the beginning again. So we have x squared minus e to the power of x minus the result of the integration by part of this. So u v first, so that's 2x times by e to the power of x. Take away integration of u dash v. So which is 2e to the power of x dx. Now we can see this can be integrated very easily. So let's continue. So we have x squared times by e to the power of x minus 2x e to the power of x plus the integration, because you have negative and negative, so that's plus, and then integration of 2e to the power of x is still 2e to the power of x plus c. Now let's have a look at another example that requires integration by part twice as well as rearranging. So we have e to the power of x times by cosine x. In fact, either one of them can be integrated very easily. That means we can pick any one of them to be our g dash. So it doesn't mean that e to the power of x has to be g dash all the time. So let's try the other way. This time, let's f to be e to the power of x, let our g dash to be cosine x. So that means f dash is e to the power of x, and g is integration cosine, so that is sine x. So let's continue substitution for the integration by part formula. So f times g is e to the power of x times by sine x, minus integration of f dash g, which is e to the power of x sine x. Now, again, from here, you need to use the integration by parts. So let's again let e to the power of x be f, and sine x will be g dash. So f dash is e to the power of x, and g is integration of the sine x, which is negative cos x. So therefore, I can rewrite the whole thing. So that will give us the left-hand side is this equals to e to the power of x sine x minus the result of the integration by part of this, so which is negative e to the power of x cos x minus integration of f dash g, so which is negative e to the power of x cos x dx. Okay, just tidy up a little further. Make sure you sort out all the negative signs. So negative become positive. So we have e to the power of x cos x. Negative become positive, but we got another negative, so it's negative e to the power of x cos x dx. Now you notice that on the left hand side we have an integration of e to the power of x cos x. On the right hand side we also have integration of that same thing. So I can actually rearrange it. So move this one to the left hand side, so it become plus. So I have 2 of integration of this equals e to the power of x. In fact, this one I can factorize it. So I have sine x plus cos x. So now the integration of e to the power of x cos x dx is half of e to the power of x sine x plus cos x plus c.